let's talk about something a little different. We're going to add halogens to your alkenes. X2 can be chlorine or bromine. Sometimes we'll do iodine, but primarily we'll focus on chlorine or bromine. Okay, so how does this work? When we have basically a nucleophile, okay, we can add on to my halogen and what you get is your nucleophile with halide and your leaving group. Okay, so let's do some examples for them. I add hydroxide and bromine together. Okay, what you get is your bromohydroxide here and a bromide. Okay, you can do the same if I added something like ammonia chlorine. Do a similar type of attack. Okay, if I add my alkene to, let's say, bromine, I get a similar nucleophilic attack. Okay, this is called bromonium ion. Chlorine and chloronium ion. Chloronium ion, bromonium ion. Alright, so let's talk about how we get that in a little bit more detail. Okay? You can get bromonium ion, chlorine, chlorinium, iodium. What's going on here? Okay. So bear in mind how large your halides are. When my alkene, okay, attacks my halogen, okay, what happens is this. These two electrons attack my halide and kicks that one out. But remember, this one will have that. Now this is going to become positive because this took both electrons. Because it starts becoming positive, those electrons from my halide come back and attack that. Okay? So, what you get is that as this attacks my halogen and I lose my halide to it, okay, the lone pair, because this is a positive charge, the lone pair comes back and basically attaches to the positive carbon. So now the positive charge is actually on my halide and not on the carbon. Okay? So that's my halogen ion. But now what happens? Well, let's see. This is a positive charge, which means I can now do a backside attack. Okay, and when I do the backside attack, is acting as a nucleophile, I can now open up my ring because this becomes a really good leaving group. What you end up with is, here's one of my halogens, 2, 3, 4, 5, 6, excellent leaving group. The backside attack from here, you get something like that. Okay, so notice the orientation. So when I add my halogen, they're going to add trans to each other. All right, so let's take a look. So in our first example, we know that they're going to add trans to each other. So let's take this carbon here. I'm going to put my chlorine here. One methyl group goes in the back. This methyl group comes out the front. This methyl goes in the front here. My hydrogen goes in the back. My chlorine adds here. Okay. Now, do I have to worry about anything? Well, turns out the only thing I need to worry about here is this, achiral center. This, 1, 2, 3, 4, it's chiral. Since I'm starting off with something achiral, I'm going to form a racemic mixture. Okay? So, this one plus is an enantiomer. Alright? So, I'll put down here, for the first one, what you're going to see. So remember, you can form your chlorinium ion like this. Okay, when my chlorine comes back as a nucleophile to attack, okay, if it attacks here, and I open it up there, that's where you get this product. Okay, if the chlorine goes here, and it opens up that way, that's how you get the enantiomer. Okay, so just keep in mind what's happening here. Now let's take a look at number 2. Okay, So we're going to add the bromine onto, this is a 1-methyl cyclohexane. Okay, so when you do that, I can have the bromine here and bromine down below, and it can open the other way. The methyl groups above, bromine is in the opposite orientation. Okay, so chiral center here, chiral center there. Okay, and you are forming a racemic mixture because they are enantiomers to each other. Okay, so when you do these types of reactions, be very crystal clear that if you are forming compounds that have chiral centers, that you make sure you write down what the enantiomers are. Make sure I know that you know it's a racemic mixture. Okay, let's take a pause here.